I'm Nix, and this is going to be another video for my Getting Started Easily on LeetCode playlist. In it, I'll solve a problem and give you all the details of the entire process, through the planning of the algorithm, to the coding of it, to the analysis of time and space complexities, as well as looking at LeetCode rankings. If that sounds interesting to you, then stay tuned. Welcome back. Now, as is usual for this playlist, the problem that I'm going to solve is going to be found by sorting this really long list of problems that LeetCode has, not by difficulty, but by acceptance rate. You can sort it by seeing the problems that have the lowest acceptance rate of all, i.e. the hardest ones, or, of course, by the highest acceptance rate, and therefore finding the quote-unquote easiest problems, which are good ways to get your feet wet if you're new to LeetCode. So going down the list, these orange locks are because I don't have premium access. So going down, a new one has cropped up, problem 2011, and this is the problem that we're going to solve. So we have a programming language with only 4 operations and 1 variable x. ++ x and x++ increments the value of their variable by 1, and of course --- x and x - decrements the value by 1. Initially the value of x is 0, and if we're given an array of strings called operations, containing a list of operations, we want to return the final value of x after performing all the operations. Okay, well, in these handy-dandy examples here, our operations, and of course it's going to be a vector of strings given to us, we have these series of strings, so we're going to decrement x by 1 and then increment x by 1 twice, so it's going to be a final value of 1, as the explanation shows. Okay, and example 2 and example 3 kind of drive home the point further. Looking at constraints here, we're not giving an empty vector, and the operations are always going to be one of these 4 things. So, how do we solve this problem? Well, in reading it, we know we're going to have one variable, x. We need an integer variable that will house that value that is being incremented and decremented. And since we're given a vector of strings that house all the operations we need to do, we're going to need to loop through that vector. And then if we see either of these 2 increment operations, we need to add 1 to the variable. And of course, if we see either of these decrement operations, we need to do its opposite. So with that plan of action, let's get to the coding. First up, we have the integer variable that we need. I called it value. You can call it x or whatever else you want. And I have initially set it to equal 0. Next up is the for loop. This is the fairly typical one. We have an integer I variable starting at 0. We're going to go as long as I is less than the size of the vector that we have. And we're going to increment I up by 1 each turn. Now come the if-else statements. For each string that we have in the operations vector, we need to figure out if it's an increment or a decrement. So if operations bracket I is equal to either the ++ x or the x++ operation, then we're going to increment the value up by 1. If that condition is not true, then we're dealing with one of the 2 decrement operations, and thus we want to decrement the value of 1. The last thing to do is outside of this for loop, once it is complete, we should return our value. And that should be all that is needed in order to successfully solve this problem. So let's run the code, see if it's accepted, which it is, and then click this submit button and see if I made any errors. And I didn't. Great! For time and space complexity analysis here, we only have one variable that's being used. It's an integer one, so that means it's going to take up constant space. So our memory usage, our space complexity, is big O of 1, constant. For time complexity, we look at the for loop here, and all we're doing in the for loop are operations that require constant time to do. So the number of iterations that this for loop is going to do stuff depends on the size of the operations vector, which we can call n. And that means that this code's time complexity is going to be big O of n, or linear. As the size of the operations vector increases, the number of iterations the for loop has to go through also increases, and thus the time it takes for the code to run increases as well. In terms of rankings, we can get the graphs by clicking on this thing here, and apparently I'm fairly high up, though take these rankings with a grain of salt. In a previous submission, when I did this first time, I was way down here when I first submitted, so you can ping pong around a bit. In terms of memory usage, it's highly clustered around, which makes sense, although again, I would expect a little bit of ping ponging here and there. Now, I want to show you a slightly different version of code that can be used to solve this problem. For this for loop here, instead of using this version of it, you can also use a ranged for, which looks like this. That ranged for is going to go through each string within the operations vector here. And now what I'm going to do is the if condition can change a bit. For each operation here, I want to look at the second character present, i.e. the character that is present at index 1, this one. Now if I see a plus sign there, then I know I'm dealing with either this operation or this operation, because in both cases, their second character is a plus. If I see that, then I know I need to increment. Otherwise, I need to decrement. And then again, after the for loop, we return the value. And as you can see, with lots of button clicking here, once it's done, the test run is accepted, and when I click the submit button at the end, it should go through here. Now the time and space complexity is the same for this version of the code as well. It's big O of 1 space complexity, big O of n time complexity. And again, from the summary that you can see here, you can see it also bounces around a bit. But just for the fun of it, let's see it in graph form. So I'm down here, but again, I've seen it ping pong around, and I wind up at the same exact place here memory-wise. So with that, that was 2 different versions of a solution for solving the final value of variable after performing operations problem. I hope you found this video useful in some way. If you did, consider subscribing. And as always, I will wish you happy coding and to have a nice day.